Yeah.
Okay, but you say, what about y is equal x? That one is just linear function. Because yesterday lesson you said.
Oh, okay. So yesterday when we were talking about lesson 4,
Yeah.
we only did the reflection
Yeah.
in the x-axis and we did the reflection in the y-axis. We haven't done this one yet. Okay? So we're gonna do that in lesson 5. Okay, so welcome everybody. It's nice to see you here and you made it here and you're looking like you're looking well and healthy. So like I said earlier, we went to lesson 4 yesterday and then we're gonna go back to lesson 3 today. So this one here is a combination of transformation. So this is we're gonna be talking about stretching and compression, reflection. Okay, so this is where everything is gonna happen. I just want to remind us the mapping that we've been doing. So, okay, so these are the transformations that we are going to be working on, the mapping. So this one tells us 1 over b, that's the horizontal compression or stretching. And if it's a negative value, there's a reflection into the y, and then there's a horizontal movement, shifting. A is a vertical stretching or compression, okay, vertical stretching or compression, and if A is negative, there is a reflection into the x-axis. Okay. And then there's also a vertical translation, either up or down. So what I'm going to do here, I find that there's not a lot of space for us to kind of show our work in here, especially if we wanted to write everything down. And I like writing everything down so that when you go home, you know, you look at your notes again. Oh, okay, now I remember this. Okay, so let's take a look at example 1. It says here, given the graph of y equals to f of x, sketch its image after a horizontal compression. So horizontal compression by a factor of, they're going to tell us what the factor is, by a factor of 1/2. And then a translation of 3 units down, so bringing it down 3 units. And it says here, write the equation of the new function in terms of f of x. So I'll just write that in here, example 1. We start with y equals to f of x. And the very first thing that they have here is horizontal compression by factor 1/2. Okay, what does that mean, horizontal compression? Which one is that? Is that the A, the B, the H, or the K? Which one are we going to be talking about there? It's horizontal compression by a factor of 1/2. So that means the factor of 1/2, that's actually it's affecting the B value, affecting the B value. So because the factor is 1/2, so therefore B is equals to, the reciprocal of this would be 2, right? So this is going to be, this is the factor 1 over B, okay? And then what's the B? B would be the 2, Okay. What else? And then translation. Translation 3 units down. Okay, which one is that one? K. So that would be the K, because it's 3 units down, it's gonna be minus 3. Okay, so what we're gonna do is we're gonna use some mapping, use some points, do the mapping, apply these transformation. So they gave us some points in here, 1, 2, 3, and 4, so we'll just use those points there. I'm telling you, I'm doing it on a separate page because there's not a lot of room. So the points that I have here is -6, +2. This point is 0, -2. This point is 2, 5. 2, 5. And then the last one would be 5, 3. Those four nice points. Okay. The transformation is going like this. I'll just write it above, and then we'll put in the right things down there. So 1 over b times x plus h, comma, a times y plus k. Okay. Now, it says here 1 over b. So 1 over b, well, that's this one over here. Or if you want, you can go 1 divided by 2. So 1 over b, that's the factor. So 1/2 times the x plus h. There's no h value, so we don't have to worry about that one, right? Is 0, yeah, 0. And it's 1 over b. So the factor is 1/2. Okay, this is really important. The factor is 1/2. That means that's the one that we are multiplying it there. Okay, but it's the b is 1. The b is 2. So if the b is 2, the factor is 1/2. 1 over 2. Right?
But what do you multiply now? Half or 2? What do you multiply?
1/2. Yeah. Okay. I'll talk about that in a second. I'll give us some examples. Is there any a value? 1. Okay, 1. So we'll just give us as y plus k. So k is -3, so -3. So 1/2 times x, comma, y minus 3. Okay, so let's work on the x's, and then we can work on the y's after. So everything is being multiplied by 1/2 or divided by 2. So this one would give us -3, 0, 1, and then 2.5. Those are the new x coordinates. Now it's y minus 3, so whatever the y value is, -3, so it's -1, -5,
+2,
and 0. Okay, so these are the new points that we have. Okay, so now what we could do is we could plot it on this graph here. Okay, so let's go ahead and plot those points there. So -3, -1. So this, did it look like it got compressed horizontally? Did it get compressed? Right? So the compression, yeah, it looks like it got compressed in this case, right? So the y stays put and it got compressed horizontally and then shifted down 3 units. Okay, is that good? Any questions there? So that's the points. Those are the new points. Now the next thing that we're going to do is just write the equation of the new function in terms of that. So the new equation the new equation would be y minus k equals to a times f of b times x minus h. So I'll give you a moment to write that down. You probably notice that I have a double brackets in here. Yeah, you're probably thinking, why is that? Because in this particular case, the b is factored out so that we are left with just the x there and then the minus h. So it's factoring out the factor of the b. And then this part here is for that one, for the f of everything in here. Okay. So, now that we have that, we could put in the values there. So it says here y minus k, well k is -3, so -3 equals a, there's no vertical stretching and reflection, so that's just 1. So you can put 1 there, or you can just leave it. F of b, the b is 2 times x minus h. H is 0 because there's no horizontal movement, minus 0. Okay, so if we want, I'll put the 1 there, okay, so that it shows the k, the a, the b, and the h. Now we can just clean it up, okay, so how can we clean this up? It's y minus -3, so that just, we can write it as +3. And then 1 times f of that would be f. And inside would be x minus 0, it's just x, and then 2 times x would be 2x. Okay, so this is the new equation. New equation after those 2 kinds of transformation.
So it is important to write the b as 2, right?
Yes, yeah. Okay, good. Now, I know that this is going to be, okay. So, I'm going to pause this for a second. I'm actually going to just kind of reset something in here, review. So let's say b is equals to 2. Let's say if b is equals to 2, the factor is 1 over b, which is 1 over 2. Okay, so if it's b is 2, the factor, that means the ones that's getting multiplied in with the x, is 1/2. If b is 3, what's the factor? Factor is 1/3. Okay. Now b is 1/4. What's the factor? Factor is 1 divided by 4, or 1/1/4, which is 4. Okay? Is that good? Now, what if we go the other way around? What if we say factor of 3? What's the b? Yeah, so therefore b is 1/3. Okay? What if there's like a factor of, and all of these are just for the b's, okay? Because the b's are the ones that are a little bit confusing sometimes for some students, okay? What if the factor is 2/3? What is the b? Okay, what's the factor? The factor is 2/3, so what's the b? 3/2. So on your function, it would look like this: y equals to f of 3/2 x. Right? It's the b that's inside, but the factor is the reciprocal. Okay? Okay, let's do a negative, okay? Let's say, now if it's a negative, then there is some kind of a mention of a reflection over the, or into the y. So let's say there's a horizontal compression by a factor of 1/4, okay, let's say like that, and a horizontal reflection, as a reflection into the y-axis. So here's the y-axis, there's a reflection into the y-axis, so the x will change to the negative. So the factor of 1/4, right? So what's the b? B is 4. Now there's a reflection into the y-axis, so if the graph is here, and then it's going to be over here. So it's going to be -4 if we combine these two. Okay? So it would look like this in the equation: y equals to f of -4x. -4x. Okay? So that's the only thing. The b is the only one that's taking the reciprocal. Okay. If it's reflection onto the x-axis, then the negative is on the outside. It's the y value that's changing, so it's f of all of these. That's the y value. So if you put a negative in front of that, then it reflected onto into the x-axis. Okay. Is that good? So that's, yeah. So we're gonna have a few more examples. I think that's it, right? So we looked at the horizontal compression by factor of 1/2, translation 3 down, new equation, and then we graphed it. Good? Okay. So now let's take a look at example number 2. Example number 2. I'll do it on a separate sheet of paper again. Given the graph of y equals to f of x, so y equals to f of x, describe and sketch the graph of the transformation represented by y equals to f of 4 times x minus 3. Okay? So what we're going to do is we're going to describe it. That means we're going to write it in words. Okay, what's happening, writing it in words. And then we're going to sketch it. Okay, so what's happening in here? What's this 4 about? Is this the A, the B, the K, or the H? The 4 is the B value. Yeah. So we know that the B is equals to 4. Okay? B is equals to 4. So that means the factor is 1/4. So when you look at this one here, when you multiply something by 1/4, does the number get bigger or get smaller? Smaller. So because it got smaller, it's a horizontal compression. Okay? So when you multiply it by 1/4, it changes to something, the result will be a smaller number. So this one is going to be a horizontal.
Is it B always a horizontal compression?
The B will talk about the horizontal compression or stretching, depending on what the B is. So this is a horizontal compression. Okay, so horizontal compression by a factor of 1/4.
That's because it's under 1, right?
Yes, yeah, it's reciprocal. Okay, yeah.
Okay. When B is factor, you put out down.
You gotta factor it up, yeah.
But this not factor. The 4 is B now, right? Why is out of the?
Yeah, I think it's factored out. 4 times x minus 3. So it's got factored out. So the B is alone. Yeah. Is that okay? Or?
Yeah.
Yeah. So that's good. What's next? We'll look at this 3 here. What's going on with this 3? Is that the A, the B, the H, or the K? It's the H, okay. So H is equals to positive 3. Very good. H is positive 3, right? Is everybody okay with that one? Okay. So if H is positive 3, what's happening to the graph? Moving it to the right. It's a horizontal. Okay, so this is a horizontal translation. 3 units to the right. Okay, very good. So it's good that we are attaching words to things like this because it helps eventually when we are thinking about it, right? It solidifies our thoughts. Okay, so what's the new picture after all these transformation? So let's take a look. Is that all? I just make sure I didn't forget anything. Okay. Now we're supposed to do a sketch. So how do we do a sketch? We're going to pick some points on this graph. Okay. So what are the good points? I'm seeing that this is a good point. -4 and 0, yes. -0 and 16, yeah. Okay, we're just gonna sketch it using those 3 points that we know it's gonna be something like that, right? So, let's look at our points. X, Y. We know the transformation is 1 over B times X plus h, comma, a times y plus k. Okay, so we know that's a transformation. That one you have to memorize because it's not going to be given.
We have to memorize that?
Yeah, that one, yeah. So now we're going to put those values in here. So horizontal compression, so that means it's going to be, the factor is 1 over b. So it's going to be 1 over 4. X plus h. So plus h would be plus 3. And then the y.
Is it plus 8 or minus?
Hmm? This one? This one?
Is it minus 8 or plus 8?
Which are you talking about? This one?
No, the formula is
The formula.
1 over bx plus h.
Plus x?
Yeah.
Is it the first one is minus h?
X plus h. Plus h. Yeah. It's minus on the equation, but on the mapping it's plus. Okay? And then a times y.
So what if it was x minus 3 inside the equation, then you would put x plus minus 3.
Come again? Yeah, sorry.
Because in the equation it's x minus 3, right? And
Yeah.
then your h would be positive 3.
Yes.
And then at the bottom it's 1 over 4x plus 3,
Plus h.
according to the a,
Mhm.
positive h, right? So what if the value is negative 3? How do you put that?
Okay, so you're changing the question?
Yeah.
Yeah, so it would be over here, it would be a plus 3. And then if this is a plus 3, that means it's going to be a minus 3.
Yeah.
So this is a minus 3, so when you put it in here, it's going to be a minus 3.
X minus something.
Yeah? I know, that's why we took the time to do the vertical and horizontal translation first, right? Because imagine learning all of this at once, and it's too much. Too much for our brains, right? So, our minds. Okay, so did we answer all of the questions before we move forward? Yeah, okay. So A is 1, okay, so that's just Y. And then there's K value, no K value. So it's just Y. Okay. So now we're gonna put in the negative 4 comma 0, 0, negative 16, 4 comma 0. So let's put those transformation in. So we're multiplying every x by a 4th, or the same thing as dividing by 4, yes? And then adding 3. So negative 4 divided by 4, so that's negative 1 plus 3, it's going to give us a 2. And then the next one, 1/4 times 0 is 0, plus 3 is 3. 1/4 times 4, that's going to give us 1, plus 3 is 4. What's that? Yeah, it's okay? Okay, sorry. And then the y's don't change, so it's going to be 0 still, negative 16, and then 0. Yeah. Okay, good. So now these are the points. So let's put those values into our thing. Okay, so now it's going to be 2, 0, 2, 0, so right there. And then 3, negative 16, 3, negative 16 right there. And then 4, 0. Okay, so I'm just going to use a different pen. I would get really, really compressed. Remember, it's 4 times compression. We're gonna just sketch it. We can't plot every single points. So the graph looks like that one. Is that okay? So what we did is we compressed this first and then move it to the right 3 units. How's that one? Is that okay? Yeah? Is it okay if we go to the next example? Yeah, we did. Yeah, so these are the descriptions. Yeah, yeah. Oh, do we have to? Oh, no, we don't need to do the new equation because this is the equation already for us. Yeah, it's already told, like they already told us the equation. Okay, good. Any other ones? Yes? Let's go to move on. What did they give us here? Example number 3 says y is equals to f of x. Okay, given the graph of y equals to f of x, describe and sketch the graph of the transformations represented by y plus 4 f of 1/2 times x plus 1 and then brackets. Okay, so what can we do? Okay, I just want to remind ourselves what the equation is supposed to be. It's y minus k equals to a times f of b times x minus h. Okay, that's what it's supposed to be. So what's happening in here is we have a y plus 4 equals to f times 1/2 x plus 1. Okay, so let's deal with this one first. What does this tell you? Minus minus, so that means what? Yeah, so the reason why it's a plus is because a minus a negative 4, right? So that means k is equals to negative 4. Okay. Huh? What's that? H is negative. Okay, you're already here. Okay. That's okay, so we'll go to this one. So this one, the reason why it's a plus 1 is because it's a minus negative. Okay. So that means H is negative 1. Okay. And what's this? And B is equals to B is 1/2. Yeah, B is equals to 1/2. Okay, let's describe it first. Let's describe this. So K is negative 4. What does that tell you? What kind of transformation?
4 units down.
4 units down, so 4 units down, okay. What does the b equals to a half tell us? Factor of 2, so factor of 2. If something is being multiplied by 2, does it get bigger or smaller? It's going to get bigger. Okay, so this is going to be a horizontal stretch by a factor of 2, right? B is a half, so that means the factor is 1 over b. So 1 over 1/2, which is 2. And then last but not the least, what does this tell us?
1 unit to the left.
1 unit to the left. 1 unit to the left. Okay? And the reason why it's 1 unit to the left, it's 1x minus -1. Okay. So we're going to use some points in here. We have an asymptote. What are the asymptotes happening in here? Can you see the asymptotes? Yeah. So x equals to 0. That's our vertical asymptote. And then the y equals to 0 is our horizontal asymptote. So what's happening here, which one is going to get affected? There's a 4 units down. So 4 units down, this horizontal asymptote will go 4 units down. So we go 1, 2, 3, 4. So 4 units down. Okay. Now, the vertical asymptote. Is the vertical asymptote getting affected by the vertical shift? This is a vertical asymptote. Can I, if I say 4 units down, it's still in the same place, right? Okay. Now, what about the horizontal shift? So this vertical will go to the left 1. Yeah, we can deal with asymptotes first. Right there. So now the new asymptote is right there. Okay, so what's going to happen? These points that they told us right there and right there are going to get transformed. Yeah, I think I should be able to fit it in here. So x comma y. So the point is -2, -1/2, and +2, +1/2. Okay, so this is going to be 1 over b, 1 over b. So which one's a 1 over b? That would be the 2. So it's going to be 2x plus h, so plus -1, so -1, comma, a is 1 minus or plus h k b, y minus 4. Is everybody okay? So first, is everybody okay with this piece? Oh, yeah, is everybody okay with this? You're lost, okay. Okay. Yeah, you gotta be honest, right? Okay, so let's go back to this one. Now we're on page 16. I'll do it here. So x comma y, the transformation is 1 over b times x plus h, a times y plus k. Yeah, okay. So because they say it's 1 over b, so b is 1/2. b is 1/2. So imagine this is going like this. 1 over 1/2. Is that better? Yeah, and you go 1 over 1/2, that's just the same thing as 2 times x, okay? H is gonna be -1, so plus -1, so it's -1. Yeah? And then A here is 1, so that's gonna be 1. Y plus K, so plus -4, so -4. So we clean it up, because we don't want to write it like that, right? 1 divided by 1/2 is just 2x minus 1, and then y minus 4. So xy maps to 2x minus 1 comma y minus 4. You okay? So let's do that one.
So I have,
Yeah.
I have one more question.
Yeah.
About the vertical and horizontal asymptotes. So if there is a asymptotes, then you use those, right?
Yeah, so move the asymptotes so that you kind of generally know where things are. And then the points, we'll do the points later. So the asymptotes are not going to be affected by compression and stretching, right? You stretch the line, it would still looks like a line. You stretch this vertical line, it would still be a vertical line. Even if you reflect it, it's still going to be in the same there. But what's going to happen is that the asymptotes are getting moved if we move things horizontally or vertically. Yeah. Did I answer your question? Yeah. Okay, so how's everybody here going? Going so far so good? Okay, good. So now let's take a look at this one. So 2 times x minus 1. Let's do the x's first. So 2 times -2, -4 minus 1, -5. Okay, I'll do the x's first so that I'm not getting confused. 2 times the x is 2, this 2, mine is 4, minus 1 is 3. Okay, now let's do the y's. Y minus 4, so -1/2 minus 4 is going to be -4.5, so -4.5, so -4.5. And then a half minus 4 is -3.5. Okay, so these are the new points, and then remember we've already moved the asymptote around. So I'll -5, 1, 2, 3, 4, 5, -4.5 right there. So this point here is now over there. Yeah? Good. So this general shape here will be right there. Remember, we're sketching it. We're just kind of using the points, some points. And then what's happening in here? This point is now located where? 3, -3.5. So 1, 2, 3, -3.5. So the graph now looks like that. Good? We'll eventually get closer and closer to that asymptote. Yes? You okay? Now, before I move on to a specific graph, can I ask you to turn your book to some of the practice questions? So we'll take a look at some practice first before we get into like really into this. If you could please